Hello and welcome. Today we are covering the 2011 Math Count State Sprint question number 12. So pause the video here and take a moment to read the question, and then return. Alright, so he is exchanging his dollar bill. That is 100 cents. And we want to make sure that the cashier gives him at least 1/4, so that is guaranteed. So let's slash this down to 75 cents, and the cashier now only has 1/4, 10 dimes, and 10 nickels. And this is sort of shorthand for the coins, as you guessed, likely guessed. And this is always great in the contest because it allows for a bit more efficiency. So picking up some habits like this is always good. Now, let's take a look at how we might be able to deconstruct this 75. So we again want to count this up in an organized manner. So let's start off with just nickels. We would need 50 nickels in order to represent these 75 cents if we were to use just nickels, because 15 times 10, or rather 15 times 5, because that's what a nickel is, 5 cents, that is equal to 75 cents. However, we're not really doing that because we don't have enough nickels for that. So let's maximize the amount of nickels instead. So let's break this down like this. So let's have nickels, dimes, quarters. So this is a very handy type of table that you can use. So we start off with 10 nickels, and then let's see. So 10 nickels takes up 50 cents. That leaves us with 25 cents. We could put in 2 dimes, but if we put in a single dime, then it's impossible to get this 5 because a dime always has a multiple of 10, and we want 25 more cents. So we'll have to skip the dimes and put in 1/4 instead. Now let's see if we knock this down to 9 nickels. So 9 nickels takes up 45 cents. We have 30 cents remaining from the 75. And let me just remove that. And that can be taken up by 3 dimes. So we put a 0 here for quarters. We can't have any other combination with a quarter and 9 nickels currently. So now let's take a look at 8 nickels. We'll need to again have 1/4 for this, but this time we can introduce 1 dime. And now if we continue similarly, we can see when we go 7 nickels, we can have 4 dimes, 0 quarters. Then if we go down 6, we can have 1, 2, 5, 5, 0. And you can sort of see it's going to continue like this. So if I continue downwards, we have 4, 1, 3, and let me move over to this side a little bit, just because I wrote myself into a corner here. So let's take a look, and we have 3, 6, 0, then we have 2, 1, 4, we have 1, 7, 0. And again, notice that we want to keep track that we do not exceed 10 dimes, and it doesn't look like we will, which makes sense because 10 times 10 equals 100, so all the dimes would be 100 cents, which is considerably larger than 75, so we don't really need to worry about that. Lastly, we have 0, 5, 1, so that's 5 dimes 1/4. Now let's see how many possible combinations this totals up to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are, in short, 11 possible combinations of coins that Javier could receive. Or Javier. Well, I wonder how I should be pronouncing that. In any case, 11 should be our answer. So yeah, I hope this clarifies this question for you, and thank you for watching.